So in our previous class, okay, we've been talking about specific latent heat. And the most important thing about specific latent heat is that it is the heat that looks like it's hidden, but actually it is doing something else. Okay, I think the most important thing that we established is that heat can only do one thing at one time. It is either increasing the temperature or it is changing the state. Okay, so when it increases the temperature, you will see a temperature increase. But when it is changing the state, okay, you will see no increase in temperature because it can only be either one. So when it's increasing in temperature, it is remaining at the same state. Okay, it is not gradually changing. It's not. It must come to a certain temperature and then only you can start to change state. Okay, this is the most important thing that we have to get past, and we have to really understand this. Okay, then I tell you, this chapter will become much easier. You need to understand that heat can only do one thing at one time. Okay, now that is in terms of what we see. Okay, it is either increasing temperature or changing state. But there is something which we call the kinetic theory of matter. Okay, kinetic theory of matter or kinetic theory of gas. Okay, some books call this gas. Okay, so the kinetic theory of matter explains what happens when there is an increase in energy, increase in temperature, or if there is a flat temperature at that. Okay, so the two important explanations for kinetic theory of matter is when it is increasing in temperature, okay, the molecules is increasing energy. Okay, if there is a temperature increase, there is an increasing kinetic energy. Okay, they are moving faster. Okay, secondly, so the heat is used now to increase the kinetic energy of the molecules. That's what's happening if there is an increasing temperature. Okay, this is an explanation using the kinetic theory of matter. Okay, now the second one is, I said just now, if it's not increasing temperature, means it is changing state. So according to the kinetic theory of matter, when it is changing state, the heat is used to break down, break down the bonds, okay, between molecules. Okay, is to break down the bonds between molecules so that they can change state. Okay, but there is one special thing. Remember that if it is from liquid to gas, it is not just breaking down the bonds between the molecules, but it is also overcoming, okay, to overcome the atmospheric pressure. Okay, so that they can become vapor, so that they become gas. Okay, so these are explanations. We say these are explanations using the kinetic theory of matter. Our observation is increased temperature or change of state. Okay, but in terms of the explanation, you will soon see okay, that they will ask you to explain using the kinetic theory of matter. So whenever you see the words kinetic theory of matter, okay, then you need to think about these 2 points. It is either, to increase the kinetic energy if there's an increase in temperature, or it is used to break the molecules between break the bonds between the molecules. But this is if the heat is absorbed. Okay, I noticed that in your homework, for those of you who handed in your homework, I asked you why the steam fish, right? Then you talk about heat absorbing, But, no, sorry. Why is it that steam is more dangerous than hot water? Okay, so a lot of you got the concept correct. You're talking about condensation, which is the change from vapor or change from gas to liquid. Okay, that is correct. Okay, but the problem is changing from liquid to gas doesn't involve an absorption of heat. And it involves the release of heat. Heat is released. Why is heat released? Heat is released not to break down the molecules. It's so that the molecules can come together. Okay, to join to strengthen the bonds between the molecules. So you need to be very clear about what which one you're talking about, you know. It's either to break down or it is to strengthen the bonds. Okay, if it is released. If the heat is released, okay, gas to liquid, liquid to solid, then we're not using the heat to break down the bonds. No, we are releasing the heat so that the bonds between the molecules can be strengthened again. Okay, or if there is a decrease in temperature, the molecules will be decreasing kinetic energy. We release the heat so that the kinetic energy of the molecules can be decreased. Okay, so so when I read your explanation about the hot water and the steam, right, I was like, how come these people are all talking about absorption of heat? We're not absorbing the heat. When steam becomes liquid, heat is released. That's why you feel hot. Okay, just ngam kan yesterday I burned my hand. I burned my hand on steam. And then I was thinking to myself, these people better get it correct. Because already so few people yang hantar kerja, and then after that, the people that hantar go and write about absorption of heat. No. The reason why we feel it's hot is because the heat is being released so that it can condensate. Okay, vapor gas change to liquid involves the release of heat. That's why we feel hot. Okay, if hot water terkena us, right, yes, it is still dangerous, it is still painful, but it is not as painful as steam changing to water. Okay, because there is a release of heat over there. Okay, all right, so let's begin. Okay, so a solid substance of mass 0.1 kg, okay, you're given the mass over here, is heated using a 200 watt heater. Now, whenever you see these 200 watts, you need to think about PT, okay, because this is Q equals to PT, the amount of energy equals to PT, and of course, since we're talking about specific latent heat, we're talking about Q equals to ML, and if there is an increase in temperature, it will be Q equals to MC delta theta. Be aware of what information that is required to find the heat energy. Okay, so based on the graph, this is originally is a solid substance, means over here, okay, it's solid lah. Okay, based on the graph, what are the states of matter between point WX, XY, and YZ? How shall we do this? Let's do this randomly today lah. Okay, Vion, can you answer all three, please?
WX solid, XY solid and liquid, YZ liquid.
Okay, very good. Okay, important thing to note is that whenever there's an increase in temperature, whenever there's an increase in temperature, there is only one state of matter. Okay, whenever it is flatlining, okay, like this, okay, it is the change from one state of matter to another state of matter. Okay, very good. Now, using the kinetic theory of matter, explain why at section XY, the temperature remains constant. Now, do you remember what I just said just now? If I say kinetic theory of matter, then you need to think about the thing that I wrote here just now. Okay, either it is used to increase kinetic energy, which is increase in temperature, or it is used to break the bonds between the molecules if it is flatlining. Okay, so how would you answer this, Bernardine?
Kinetic energy of molecules don't increase.
Okay, because why is there no increase in kinetic energy? It's an important fact, actually. Anybody want to try? Want to help Bernardine? Why is there no increase in kinetic? She has the first point. 1 point is there, but it is a 2-mark question. I don't know if it is written there, but I think it is a 2-mark question. Why is there no increase in kinetic energy?
Because the heat is used to break down the bonds between molecules.
Okay, very good. Okay, the heat or the energy is used to break up the bonds between the molecules, which is why there is no increase in kinetic energy. Okay, so try as much as possible when you answer things like this, especially when you're trying to explain. Okay, this is a tutorial, so this is why we learn how to answer questions as we learn as well. Okay, in using the kinetic theory of matter, try to be, go all out with your explanation. Don't be stingy and say, oh, just one sentence is okay enough lah. No, not necessarily. Okay, sometimes you need to use more words. Okay, now at section YZ, why is there a temperature increase? Steffi?
Heat is absorbed.
Okay, two.
I just write heat is absorbed or diffused.
Oh. Okay, what is the heat used for? Must talk about what is it used for. Correct, heat is absorbed, but for what? Oh, temperature increase. Because heat absorbed does not always mean temperature increase. Heat absorbed can mean either temperature increase or temperature constant. But what is the heat used for if the heat is absorbed? Anybody?
Increase kinetic energy.
Okay, in this class, anybody means Wong Yik Swan. Everything also is Wong Yik Swan. Okay, so the kinetic energy increases. Okay, temperature is directly proportional to kinetic energy. Very, very important. Doesn't have to be in these same words. Okay, Steffi, if you're using your sentences now, heat is absorbed to increase the kinetic energy. Full stop. I would end there. Okay, heat is used to increase the kinetic energy. Okay, you can put this second sentence if you want in as an added line. But the main thing is this, when we talk about kinetic theory of matter, as I said just now, when we talk about kinetic theory of matter, we must be able to explain what the heat is used for. Okay, what the energy is used for. It's either to increase the kinetic energy or to break up the bonds between the molecules. Okay, either one of these two. All right, using the graph, determine the melting point of the substance, and then after that, the specific latent heat of fusion of the substance. Chen Yi.
XY. Wait. 0 Celsius.
0 Celsius, okay? 0 degrees Celsius. What is the specific latent heat of fusion?
XY.
Oh no, okay. I know it's XY. Okay, so the specific latent heat is at this part lah. But I think the question is asking for what is the value of the C. Okay. So you need to use, it's okay. Sorry, what is the value of the L? Okay, you need to use PT equals to ML. And we already know how many minutes is here lah. Okay, it is 2 until 9, so it's 7 minutes. Okay, but since we're using T in seconds, we need to change the seconds to minutes to seconds by multiplying by 60. Okay, so this one, guys, this one comes from PT equals to ML. Okay, we want to find the value of L. P is the power 200. T is 7 minutes, but we have to times by 60 to change it to seconds. And then M is the mass, 0.1 kg. Okay, so remember, this is the power from the heater. The heat from the heater changed to the specific latent heat in order to melt the substance lah, okay, to become liquid. So the amount of heat, the specific latent heat is 840,000 joules per kilogram. Okay, be very careful with this. Sorry. I think somebody last week in the class, you asked me, how do I get this formula right? It's not really a formula. Dia datang daripada sini. Because we established that Q adalah sama dengan PT. Q also is equals to ML. Okay, so the heat from the heater is the PT lah. And the heat that is used to melt is ML. Okay, so kita pindah-pindah and then we will get this thing that you see over here. Okay, all right, moving on. Now, sweating is one of the ways our body maintains the body temperature of 37 degrees Celsius. Okay, our internal body temperature is about 37 degrees Celsius. Generally, it is accepted that body temperature is 37 degrees Celsius. Room temperature, this is good for chemistry. Room temperature is always 27 degrees Celsius. It's very important that our body is hotter than the room. Because if the room is hotter than our body, then the heat will come into our body, which is not a good thing. Remember thermal equilibrium. We are always touching the room. We are always touching the gas around us. So if we are hotter than the gas, then the heat from us will go outside to the air around us. But if the air is hotter than our body, then the heat from the air will go into our body, which is not a good thing. Okay, so generally room temperature is lower than body temperature. Okay, so sweat is largely made out of water and it comes from sweat glands as shown in this figure. So a little bit of biology here. Now, when sweat evaporates, okay, it takes heat away from our body. Okay, and this one, I think you all mentioned, this was in the assignment that I gave you, right, about the sweat, about what happens when it sweats now. Okay, so again, using the kinetic theory of matter, okay, explain how evaporation takes away heat from our body. Basically, it is the same explanation as I asked you to do in last Friday's class. Okay, for those of you that hantar lah. Okay, so I won't ask anybody to answer this, but this one, this is how it is lah. The heat is used to break up the bonds between the water molecules, and the heat is absorbed from the body. Okay, that's why when evaporation happens, so for those of you yang hantar, I give 1 mark for the word evaporation lah. Okay, because it is not mentioned there, evaporation. So evaporate is 1 mark, and then the second mark is heat is absorbed from the body to break up the bonds. Okay, so in this particular question, okay, we have to talk about the heat is used. Okay, heat is used, okay, to break up the bonds between the water molecules. And where does the heat come from? The heat comes from our body. That's why when we sweat, and the sweat evaporates, our bodies will feel cooler. Okay, we are designed that way, so that, and it is a good thing. Imagine if we are sweating, and then after that the sweat releases heat into our body, we become even more hot. This is not a good thing. Okay, so when sweat evaporates, of course it's very yucky when we sweat but when sweat evaporates, okay, it needs energy in order to evaporate because it is liquid changing to gas. So liquid change to gas must absorb heat. Where is it going to get the heat from? It's going to get it from our body. That's why we feel cooler. Although we feel tired when we are sweating, but we feel cooler. Okay, when sweat evaporates. Okay. All right, question B. While playing badminton, 0.05 kg of sweat was evaporated from Ahmad's body. Calculate the quantity of heat lost from his body due to the evaporation. Quantity of heat is just Q. Okay, the latent heat of vaporization is 2.3 times 10 to the power of, I can't read this lah. Okay, but can I have the answer, please? Rahman? 1150000. I guess so. Okay, yeah, 1150000. What's 1.15 times 10 to the power of 5? 1, 2, 3, 4, 5. 1150000. 3 zeros. Okay, you are giving me 4 zeros. Why? Why 4 zeros? 2.3 times 10 to the power of 6, right? Is it 6 or 5? Should be 6 because it's vaporization. Okay, 1.15 times 10 to the power of 5. Okay, try in the future, please, to unmute yourself because I have to keep switching back and forth between the PowerPoint and this one. All right, next. Diagram 1 shows the change of phase when 1 kg of ice is converted into steam. Okay, name the heat energy Q1, which is absorbed from R to S. Can I have Carlson for this, please?
Latent heat of fusion.
Okay, very good. Latent heat of fusion. This is even better. Okay, because it is changing from ice to water with no change in temperature. Okay, so no change in temperature means latent heat, and then ice to water is fusion. Very good. State one reason why the temperature at R and S is the same. Okay, look, why is it the temperature is the same? Okay, even though heat is supplied. Joey. I need to take off who I called and who I didn't call. Sorry, Joey?
Heat is absorbed to break down the bonds between ice molecules.
Very good. Okay, such an excellent answer. Okay, even this answer also not so good. Your answer better. Okay, heat is absorbed. Very nice. Okay, to break up the bonds between the ice molecules. Even better. Okay, calculate the calculate the heat energy Q2, okay, which is absorbed from S to T. S to T, this is a change in temperature. So, which formula do we use and what is the answer? Can I have Ari for this, please?
Dah tahu, saya dah tahu jawapannya.
Okay, if you are given the specific heat capacity of water, which is C, okay, then obviously the formula that you need to use is Q equals to mc delta theta. M is given 1 kg. C is given 4,200. Problem is, what is the delta theta? What is the change in temperature? If you read the diagram properly, it's 0 to 100. Okay, so your answer will be 1 times 4,200 times 100, which is 420,000 joules. Okay, again, to remind you that it's a difference in the formula that we use. No? We cannot just because this subtopic is specific latent heat, maksudnya semua formula adalah Q equals to ml. Cannot. Okay, it cannot be detached that way. Everything is somehow connected to one another. And we need to be able to be flexible in our thinking to know that, oh, okay, sometimes soalan ni akan bertanya pasal specific heat capacity. Okay, so knowing the formula is a very important thing that we need to grasp. Okay, sketching the graph. So the graph of the temperature actually has already been sketched for you. Most important thing is 0. Okay, this is the first one, R to S. So actually R is here, S is here, T is here, U is here. Sorry, T is here, U is here, sorry. Okay, R, S, T, U. That's what I want to see. Okay, diagram 8.1 shows 500 watts. Once again, if you see watts, then you're talking about Q equals to power times time. Okay, being used to heat a beaker of water on a compression balance. State the energy change involved when using the heater to heat the water. Can I have Iril for this, please? Assuming that Iril is here. Is Iril here? Yes, Iril is here. Iril, can you answer question A, please? When you use heat to heat the water, it's just electrical energy to heat energy. Oh no. I need to ask who your Form 1 science teacher is, right? And call him or her to come and slap your face. This kind of thing, you should not be able to answer. Okay, change electrical energy to heat energy. Okay, energy change. Perubahan dari tenaga apa kepada tenaga apa. Tenaga apa kepada tenaga apa. Okay, the mass of water 0.5 kilogram. Specific heat capacity of water is, this is a mistake, people. There should be 4,200, not 42,000. Okay, the initial temperature is 30 degrees Celsius. Okay, calculate the energy absorbed by the water to reach its boiling point. Okay, boiling point is what? 100 degrees Celsius. Okay, so what would the answer be for this? Okay, since I give 42,000, I will give you the answer. Okay, it will be 0.5 kilograms, 4,200, not 42,000. And then the change in temperature will be 30 to 100 degrees Celsius. So what this question is not telling you is the boiling point. Okay, of course, the boiling point of water, everyone who has learned science at Form 1 should know this now, okay, it's 100 degrees Celsius. You shouldn't even be asking this question, what is the boiling point of water? Okay, jangan sampai kau tertanya soalan ini pada tahap Form 4 Physics. Okay, don't be an embarrassment to yourself. Please know this, okay? Ini semua orang tahu ini. So 147,000 joules. Okay, we use the formula Q equals to mc delta theta. Okay, now when the water is boiling, the reading of the compression balance decreases by 0.0125 kilogram in 60 seconds. Calculate the specific latent heat of vaporization of the water. Okay, can I have Meryl for this, please? Specific latent heat of vaporization, we're talking about L. We have to use PT equals to ML. We want to count L. The mass I use 0.4875. Oh, okay, okay. You use 4875 because 0.5 originally, right? Then it decreased by this one. Okay, I think I know what happened now. Okay, first of all, we need to ask ourselves, why is the mass decreasing? The mass is decreasing because this is the amount of water that has already changed to gas. So in order to count the specific latent heat of vaporization, we need to know how much has already been changed to gas. That's why we still use, that's why we still use 0.0125 down here. Okay, this is PT equals to ML in case anybody is still asking. Okay, so the power times time is here for 60 seconds, but the mass is 0.0125 because that is the amount of water that has already changed to gas. That's why this question, what this question is not directly telling you is that the amount of water that has changed to gas is 0.0125 kilograms. Okay, so we're not interested in how much water there is left, which is I think where Merrill used 0.4875 lah. Dia pergi tolak 0.5 and 0.0125, which is the amount of water left in the yang belum jadi gas lah. Okay, but that one we're not interested. We're interested in how much has already become gas. Okay, which is 0.0125. All right, no problems. Okay, so this is where we learn. All right, next question. Q, R, and S are three different hot plates. These hot plates are used to heat up roti canai. Wow. Okay, and you have all these characteristics of each plate lah. Okay, first of all, the initial temperature of each plate is 30 degrees Celsius. The plates are ready to use when the temperature reaches 200 degrees Celsius. Okay, calculate the time to reach 200 degrees Celsius for each plate. Now, this is specific heat capacity. So totally nothing to do with latent heat. But let's consider this. Q equals to MC delta theta. Okay, but you have the power over here. Okay, you need to calculate the time. So we are talking about PT equals to MC delta theta for each case. Okay, calculate the time. Okay, can I have the three people that got the wrong answer just now to answer this, please? Ari, Iril, and Meryl. Ari, Iril, and Meryl. Okay, please use this formula to calculate for me. So let's have Ari for Q, Iril for R, and Meryl for S. Whenever you're ready, just let me know. 302.22. Okay, Meryl is done. Ari and Iril waiting for you.
331.5 seconds.
331.5 seconds. Okay. Left Iril. 331.5 seconds. It's a very basic substitution. Okay, macam mana kita dapat 170 because the difference in temperature is 200 minus 30. Okay, so good for you, Ari. So Irel's want to be 318.75 seconds. Okay, and Meryl's, as she correctly shown, is 302.22 seconds. Okay, so based on the answers, based on these three answers, okay, which plate is the most suitable for heating up roti canai?
Plate S.
Why S? Okay, because it heats up faster. Okay, it takes a shorter time to heat up, so you don't waste energy. Okay, so and we want it to be fast, because you want to heat up roti canai, it don't take up too long. Okay, so it uses the shortest time taken. All right, next question. The meaning of specific latent heat of fusion is given in your workbook. Okay, so I'm not going to waste time here. Again, explain why the temperature does not change, okay, when the ice cubes change to solid. Nikki, explain why the temperature does not change when the ice cubes change to solid. Liquid.
Because the heat is used to break the bond between the molecules.
Okay. And sorry, there are 2 points to this. One is the heat is used to break up the molecules, but you still haven't explained why the temperature does not change. Go all the way. Don't even stop halfway. It's because the kinetic energy does not increase. Okay, actually the first one is good already lah. Okay, you did very well on the first one. But I suspect that this is a 2-mark question, so you need to talk about the kinetic energy as well. Okay, the kinetic energy does not increase. That's why there is no temperature change. Okay, again, the point I have been saying since turun temurun, the kinetic energy has always to do with the temperature of the molecules, the substance. Okay, the higher the temperature, the higher the kinetic energy of the molecules, until it flatlines. Then we're talking about breaking up the bonds between the molecules. Okay, C1 now, calculate the energy absorbed by the ice cubes. Can I have Kahao for this, please? And then the mass, let's have Kahao for this, please. Energy absorbed by the ice cubes. How do you get 36,000? You can either unmute yourself and tell me, or you can type it out lah, no problem. Type out lah. Type out just means longer time and more menyusahkan for you. But, lah. 600 times 60. Okay, we use E equals to PT. 600 times 60 and you get 30,000. Don't forget the unit. The unit is joules. So the mass of ice cubes that have been melted. Okay, we need to know that since this is melting and they only give specific latent heat, so we are talking about finding the value of M. Okay.
0.109.
Okay, 0.109 kilograms. Okay, or 0.109 or 1.09 times 10 to the power of -1 kilograms. Okay, good. All right. Specific latent heat of vaporization is already given in this one, so I'm not going to waste time there. Explain why someone who is sweating feels cool when he is rotating under the fan. Again, sweating involves evaporation. So this one I'm not going to do this one because we've already this one. But we need to talk about rotating fan. Okay, rotating fan, we have to talk about the speed of the moving air increases. So the speed of the moving air increases, so the rate of evaporation increase. When the moving air is, that's why whenever we're sweating, we sit in front of a fan, okay, so that we can have more air moving. Because the more air moves, okay, the faster it will evaporate. And when the faster it will evaporate, the more heat is taken away from our body. So actually, if you think about it, the fan, the function of the fan is not directly to cool you down. The function of the fan is just to provide more moving air so that the evaporation can happen. More evaporation can happen. And when more evaporation happens, more heat is being absorbed from the body. So we need to get this straight, people. It is not the fan that is cooling you down, It is the evaporation that is cooling you down. You feel colder because when sweat evaporates, it will absorb all the heat from your body. Okay, so we have to unlearn what we learned last time. We think that we sit in front of the fan means, we will cool down faster, which is true, but it is not because of the fan. Okay, it is because of the evaporation that we are cooling down faster. Okay, calculation. Let's do this. Okay, calculate the specific latent heat of fusion of the substance. This one. And the specific heat capacity of the substance in the liquid state. So we need to talk about this. Originally it's solid. Okay, so this is the same as the first question. So this is solid, here is solid plus liquid, and here is liquid. Mass is here. Immersion heater of 240 volts, 0.1 kilowatts, which we want. This is our P. Okay, if you've taken a look at all the units before this, we are only interested in watt. We're not interested in the voltage. Nothing to do with the voltage here. Take a look at the difference in temperature. Calculate the specific latent heat of fusion of the substance. Fusion. Specific latent heat means we're talking about this section. Okay, can I have Chloe for this, please? Let's have Chloe for number 1 and Ethan for number 2. 312,000 joules per kilogram. Can you explain how you got that, please? 100 times 156 times 0.05 L. Oh, okay. Yeah, correct lah. Okay, it's 312. I'm just wondering where you got the 156 from, but it's probably because of the 2.6 times 60. No. Minutes, right? Yeah, 2.6 and 60 is 156. 2.6 and 60 is 156. Yeah, okay, fine. 31200 0. Okay, joules per kilogram. Sorry, Ethan, did you say something just now about the number 2?
Yeah, but I think my answer wrong.
What's your answer?
2800.
2800. How do you get 2800?
218 minus 78 divided by 0.05.
Okay, it's 140 degrees Celsius. Why divide by what? Divide by 0.7.
The mass, 0.05.
Oh, divide by 0.05. Not enough information though. We're looking at this, PT equals to MC delta theta. So the good thing is you found the 140. I want to find the C. The mass is 0.05. Power and time, power does not change. Power is still 100 because 0.1 kilowatts you change to 100 watts. The time according to this graph, where it is in a liquid state, this one is 3.6 to 1.8. So it's 1.2 minutes, but we change to seconds. Okay, so P is 100, T is this one, mass is this one. You can calculate the C lah. Okay, and you will get the C equals to 1029. Okay, so this question, okay, I put this question in is to show you all that when we do a calculation question, right, it's sometimes not as straightforward as, just begitu tambah satu tolak satu habis. It's not just that lah. We have to consider the fact that the rules tell us that power has to be in watts, time has to be in seconds, and we have to consider the energy change. This is heat energy. Sorry, this is electrical energy change to heat energy. Heat energy got two types. It's either MC delta theta or it's MC or it's ML, depending on which situation we want. So there are many things to consider when we're doing a calculation question like this. I know that I'm over time. Just give me another 2 more minutes. Okay. So there are many things to consider, okay, when we're doing a heat question. And that's why this chapter is usually considered by a lot of students to be a very challenging chapter, because you not only have to grasp the explanations, okay, ada banyak penjelasan. You have to think about the kinetic theory of matter and blah, blah, blah. You also have to grasp the calculations. Okay, so it is a difficult chapter. I am not saying it's probably the most difficult chapter, I think, in Form 4. Okay, it's not the most difficult chapter in the entire syllabus lah, but in Form 4, this chapter is the most difficult because ada banyak penjelasan dan ada banyak pengiraan. Okay, which is everybody's nightmare lah when it comes to physics. Okay, so this will be your homework for today. Once again, please answer in a table form. Okay, please answer in a table form. Characteristics. Okay, explanations. Yada yada. Okay, and then you have to make the best choice lah. Okay, make the best choice for the radiator. There are 4. Okay, either you use a small fan or big fan. You use many fin blades or little fin blades, the boiling point, and the specific heat capacity.